So sorry.
Okay, just waiting for this to show up. Oh, there we go. Okay. So good morning, everyone. I'm Michael Jansen, and as you heard, I am the co-founder and chief business officer at a company called TwinMaster. I'm joined today by my colleague, Dr. Prasanta Bose, who is also a co-founder and CEO and CTO of the company. We have about 20 minutes together today, and we're going to use this time to make a very clear argument about where AI is in AEC, actually right now, and more importantly, where we think it needs to go. Over the past 18 to 24 months, the AEC industry has been flooded with AI tools. Image generation and conceptual rendering, text to floor plan and text to 3D workflows, AI for construction documentation and detailing, specification chatbots, RFI co-pilots, quantity takeoff and estimating tools, generative design systems, code compliance checkers, energy and sustainability predictors. Some of these tools are genuinely useful, and they indeed do automate real tasks, and they do save real time. But if you step back and look at what they actually offer and what they don't, it's revealing. Buildings are indeed complex systems, and what we have today is candidly a lot of simple task automation and very little complex thinking. This is the real challenge of architecture and engineering. Every single project requires teams to simultaneously reconcile 20, 30, and sometimes even more competing objectives. Cost and budget constraints, carbon and embodied emissions, energy performance, daylighting and occupant wellness, zoning and planning rules, structural integrity, constructability, procurement and supply chain risks, life cycle maintenance, acoustic performance, accessibility, comfort, daylight exposure, client intent, and aesthetics, and so on and so forth. And here is the critical point. These objectives do not exist in isolation. Every decision about one affects all of the others. Change the facade system and you've simultaneously changed the energy model, the carbon budget, the cost, constructability, and even the schedule. The complexity is enormous, and it is very real on every project that we deal with every day. So there's so many things to think about, and no tools really to improve that thinking.
Excuse me.
Okay, so here. How's that? Thank you. Most current AI systems and AEC still operate inside narrow silos. A rendering system, for example, does not understand constructability. A code checker does not understand carbon impact or procurement risk. A specification assistant does not understand life cycle performance. Most chatbots can retrieve information, but they cannot reason across the full complexity of a project. The result is that most current tools offer single outputs rather than optimized project-wide outcomes. They each do their small job very well, but they don't talk to each other and they don't reason together. And buildings fail when decisions are disconnected. This distinction is the most important one that I'd like to leave you with today. There are two fundamentally different ways to think about AI in AEC. The first is AI as a feature, standalone co-pilots, workflow automation, isolated solutions, single task optimization, and most significantly, we see a lot of AI bolted onto BIM 1.0 and BIM 2.0 tools that were never actually designed for it. The second is AI as infrastructure. That's where we get into AI native interoperability, semantic digital twins, cross-phase, cross-discipline, and cross-platform intelligence, multi-objective reasoning, multi-objective decision intelligence, and context-aware lifecycle reasoning. Most of what you see in the market today sits in the first category. TwinMaster specifically was built for the second, because our view is that AI is not a feature, it's the next big thing after BIM. BIM was indeed transformative. It digitalized geometry and documentation and fundamentally changed how buildings are designed and coordinated, but BIM did not solve decision making. It made decisions better documented, but it did not necessarily just make them better. The next layer to assist with this, obviously, is intelligence. AI native systems can now reason simultaneously across carbon, costs, daylight, constructability, compliance, life cycle performance, and so on and so forth. And it does it in seconds rather than hours, days, or weeks. Semantic digital twins transform BIM models into machine-understandable knowledge systems that evolve with every project. And importantly, intelligence systems will not replace authoring tools that you all have become used to working with. They will operate above them, orchestrating insight across the entire ecosystem simultaneously. Let me show you what this looks like. I'm going to play a video for you now that's going to show our AI co-pilot called Archie, which is a cognitive reasoning platform working directly inside the tools that architects and engineers already use. Archie is learning to think like an architect and reason like an engineer. And with that, let me play the video.
The building industry doesn't have a modeling problem. It has a decision intelligence problem. The software we use works in silos, and it has for decades. Design teams waste precious time bouncing between tools, manually reconciling cost, carbon, energy, zoning, risk, and other critical KPIs, with every design change triggering reevaluation, cross-disciplinary coordination, and guesswork about the best path forward. This fragmented process costs the AEC industry $280 billion every year. The result? Projects fall behind, budgets run over, risk escalates, design quality suffers. That's why Archie was born. Archie is an award-winning AI platform purpose-built for architecture, engineering, construction, and operations. At its core, Archie is a cognitive AI co-pilot performing real-time, multi-objective reasoning across the decisions that shape buildings. It's an intelligence layer that sits above the tools you already love and trust. It doesn't replace them, it amplifies them. Archie consumes outputs, reasons across platforms alongside your design intent, and delivers decisions you can trust, pushing results directly back into your original design tools to ensure a seamless workflow. It thinks like an architect and reasons like an engineer, and it does it in seconds, not hours, days, or weeks. No more interoperability chaos, no more wasted design hours, no more decision paralysis. Archie doesn't analyze performance metrics in isolation. It evaluates trade-offs between them. Instead of running single-point simulations, it performs multi-objective reasoning using AI, weighing cost, carbon, energy, comfort, zoning, constructability, and lifecycle performance simultaneously. Start with your design. Import your model into TwinMaster and watch Archie go to work. Here, Archie evaluates zoning compliance, energy performance, daylight studies, and embodied carbon simultaneously. No separate reports, no spreadsheet gymnastics, no manual reconciliation. This is enhanced decision intelligence. Archie thinks across the entire building lifecycle, from concept through operations. Operational consequences surface early, while decisions are still flexible. By bringing lifecycle intelligence into the earliest stages of design, Archie enhances team efficiency, reduces redesign cycles, and compresses planning timelines. Archie complements and enhances the work architects and engineers do every day. It does not replace expertise, it amplifies it. A once-in-a-generation shift in AEC practice is underway. AI will transform how buildings are designed, and the firms that move first will define what comes next. Request early access to book a live demonstration. Visit thetwinmaster.com.
Thank you for your patience with that. So this shift is happening now because the industry's largest software ecosystems are actively preparing AI-native workflows, and TwinMaster is already engaging with them. We now have integrations and marketplace partnerships across Autodesk, Bentley, Trimble, and the McNeil software ecosystems, including with Revit, Construction Cloud, Bentley, MicroStation, SketchUp by Trimble, Trimble Connect, and Rhino, with others to follow soon. We're also now formally either listed or soon to be listed in the Autodesk App Store, the Bentley Partner Ecosystem Catalog, the Trimble Marketplace, and Food for Rhino. And we believe that this reflects the broader industry shift towards AI-native workflows and decision intelligence. If you'd like to come and speak with us, we're out in the hall number 20. It's here at booth number 20. We'd love to speak with you. The future will not belong to isolated AI applications operating independently, but it will belong to intelligent systems embedded across the broader design and construction ecosystem, and that future is already beginning to take shape. The first generation of AI and AEC focused on acceleration, doing the same things faster. The next generation will focus on intelligence, making better decisions holistically, informed by better reasoning across the full complexity of a real project. So the market is shifting. It's shifting from automation to reasoning, from isolated tools to connected ecosystems, from data access to decision intelligence, and from workflow assistance to cognitive infrastructure. The firms that master AI native decision intelligence will gain a structural advantage in cost, speed, sustainability, and overall design and delivery quality. The next decade of AEC will not be defined by who generates geometry the fastest. It will be defined by who consistently makes better decisions at every phase of the design, build, operate lifecycle. TwinMaster believes that the next software category after this BIM is actually intelligence. I'll now hand things over to my colleague, Dr. Bose, to take forward.
Thank you, Michael. Let me take you kind of one layer below what Michael said. And what I'll try to do is give you kind of an architectural understanding of TwinMaster. So as you can see here, the TwinMaster engages different forms of interaction that is typical of the kind of data that one faces in an architecture or an engineer faces. So you have data which is in the form of 3D, or in dashboards, or in these kinds of compliance or cost tables that you can see here, right? Then the next layer that you see here are basically the different data sources that is actually fueling the digital twin architecture here. And then in here, you're seeing basically the basic sets of activity, the workflow that takes you from ingesting to semantic lifting, to then the AI reasoning engine or the different agents that come into play as they interact with the user, the insights that gets created, and then the decisions that get made. Obviously, each of these stages that you see here are powered by different kinds of agents that are spanning, I'll show you in a moment. So out of this, what you can see here are these three foundation thinking that is coming here, right? That is, one is that being able to then have a model of the world, in this case, the building, right? The one that is being designed and constructed and being operated. And then being able to do connected decision making, because I'll make you the kind of the vision that what we are after is that ultimately the challenge is because of the complexity of this building and the cross-cutting interactions between the different disciplines, the objectives and the constraints leads to kind of interactions that must be addressed, and that's where you get the sweet spot of where AI really helps you to achieve better productivity and speed. And then on top of it, if you're using AI and the reasoning, how do you create, you can say, trusted decisions and something that people can have confidence on, that is being able to ground it in terms of the data and the tools and the reasoning that is going on. So this gives you kind of one layer below, kind of a more deeper understanding of TwinMaster architecture, which is, as I was telling you, the different apps that is interacting, whether it's the world app, the building app, the community, the agentic layer with the different 8 kinds of agents, which are kind of, you can say each of them is a specialist in each domain, whether it's a cost or compliance, design change, or different kinds of KPI agents, like carbon, let's say thermal comfort, or is to do with the onboarding, where you're converting, onboarding a Revit model and converting it into a kind of a knowledge graph. And then there are these also clash agents and their corresponding skills. The skills, I don't want to kind of go in there. The key point is that each agent is using, you can say, procedural knowledge or skills, which is actually interacting with different kinds of tools. They can self-configure depending on what the task is. So then the next layer that you see here is basically the digital twin layer, which is both the knowledge graph of the different entities and the relations. And then the correspondingly, you can say the extended version of the digital twin as it evolves from being reasoned about and going into the construction phase and into operation. And so the data sources that you see here, obviously we do not, the way TwinMaster is architected is to sit above all of these, you can say, the different data hubs. So we interoperate with whether it's the, you can say the Autodesk Cloud or the Trimble Connect or the Bentley iTwin, right? All of those data sources, we basically being able to move back and forth easily, being able to bring the data into our platform, being able to reason, and then being able to then push it back, into the source systems. So what is driving, if you pause for a moment and you say, well, where is AI? AI isn't just generating, text, generating building, but where is the hard problem? And this is where we kind of, the vision that we are after is this thinking about this X-aware architecture. Because at the end of the day, because if you look at the architecture with this different disciplines, different systems, and the objectives that is appearing in different life cycle stages, you have to wrestle with the fact, how do I make this building cost aware, right? Because you don't have infinite resources, infinite cost. How do you make it constructible? Whatever the design is making, whatever the facade, is that constructible given the material, given the resources that you have at that locality, and so on. So that challenge, that is the kind of you can say all architects, all builders face. And what Archie is, the TwinMaster platform is helping you to do is kind of reason about the connection between these kinds of constraints and objectives, and at the end of the day, help you in making the right trade-offs that ultimately make you better buildings. And so this matters because at the end of the day, when you make this, if you do not understand or identify those interactions, they, down the life cycle stages, they come to bite you in terms of the cost overruns, compliance failures, or that, hey, you know what, I need to now totally, I have already built the first floor, now I have to go back and break it again, redo the whole thing. And so those are not sustainable. And so this is the fundamental way we are proceeding, how we have architected this, you can say, the overall TwinMaster and the agents being able to enable you to address and make the building conscious or X-aware. So again, I'm kind of reiterating the foundation that is driving TwinMaster. Obviously, there's this X-aware reasoning process, being able to do this multi-objective trade-offs, being able to use a model of the world. The digital twin gives us the model which is continuously persisting throughout the life cycle, and then being the agents as kind of giving that agentic digital twin, that the twin becomes an organic living entity that is helping to interact and advance as the building advances over the life cycle stages. So what we think is that this next generation, when we say BIM 2.0, 2.3, it's actually the agentic digital twin is you can say the next gen BIM. That's what we think. And with this, the way it operates in this kind of outcome driven and context driven, and with obviously, I did not go into this, there is this aspect of that we strongly believe is not fully autonomous. It's about how we talk about human in the loop, how human supervises, how the agents continue to iterate and become recursively more and more better. And so that is the only way we think the trustworthy systems, that means agents can expose what they're reasoning about, the agents can take your feedback and continue to improve or actually repair, right? So those are some things which are by design built into TwinMaster. So I would close as I was giving you the overall thing that today, tomorrow's architecting, building and operating is not about generating yet another tool, yet another thing. It's about being able to making stitched or connected relations and making the building aware of some of these traits early on, so that you do not actually go back and backtrack and you make any waste decisions. So how do you make better decisions and better buildings and sustainable buildings? So with that having said, if you want to try out what that X-aware, digital twin that is helping you to make your lives better, you can say your work better and better collaboration and better decisions, I would love to have you guys, try out. We are open for beta testing, and so it's initially we are having the next 3 months, maybe. It's free, so you could try it out with your come with your models, come with your challenges. I would love to hear from you.
Thank you.
Thank you.